Okay, let's do this example. I will I will be going faster in this example than I did in the first one. So feel free to refer back to the original example if you want to see all of the details worked out more explicitly. Okay, so the first thing is to figure out the coefficients, and I'm gonna write a few of the terms, and that's gonna give me just so I can get a sense of what this is, right? So what am I working with? So I've got n starts at 0, right? So I've got a series here. It's 1 over n squared times x to the n. Now, first thing I notice is that, oh wait, I've got a typo. This should be n equals 1, right? Because I can't divide by n equals 0. So let's just change that. That's a typo, and I'll change it to reflect on the module. But now when n equals 1, I'll just have 1 times x, n equals 2. I'll have x, well, it'll be x squared, so it'll be 1/4 x squared plus 1/9 x cubed plus dot dot dot. Okay, so my coefficients are going to be 1, 1/4, 1/9, 1/16, dot dot dot, and a formula for a sub n is 1 over n squared. What is my center? My center is going to be 0 because it's as though my terms are 1 over n squared, x minus 0 to the nth power. Right? So my center C is actually going to be 0. And now let's jump straight to finding R. R is our radius of convergence. So I want to find R and the endpoints. And I'm going to choose to use, I could use the ratio test, I could use the root test. I'm just going to use the ratio test. Let me add a page below. So I'm going to use the ratio test, using the ratio test to find R and my endpoints. Okay, so I've got my series, and it is x to the n over n squared. So using the ratio test, I'll have x to the n plus 1 over n plus 1 squared divided by x to the n over n squared. Okay, this is I want to take the limit as n goes to infinity of the absolute value of this. This is going to be my L. Right, so this is equal to L. And then by looking at the limit of the ratio of consecutive terms of the power series, I'm able to determine that if L is less than 1, my series converges, and it converges absolutely. If L is greater than 1, my series diverges, and if L is equal to 1, no conclusion. Okay, so let's go ahead. The next step, of course, is to simplify. So when I simplify, I'll get x to the n plus 1 over x to the n. Then I'll have n plus 1 quantity squared and n squared. And I've still got absolute values. And here we can do some more simplifying. So I have the limit n goes to infinity, because the x to the n and the x to the n plus 1 are going to cancel out. And I'll just have x. And then I'll have n squared over n plus 1, quantity squared, absolute value. And then this is equal to. Now notice that I can remove the absolute values around the n squared and the n plus 1 squared, n squared over n plus 1 squared, because absolute value of n squared is just going to be n squared, right? So since n is a positive number, n squared and n plus 1 squared are going to be positive as well. Now the next thing I can do is I can pull this absolute value of x to the front. And so since the absolute value of x is not involved with the limit as n goes to infinity, we have the absolute value of x times the limit, n goes to infinity, n squared over n plus 1 squared. And I want to say a word about showing your work. Keep in mind that it's important, it's not just important to get the quote-unquote correct answer. It is important to show correct reasoning. So be careful as you're writing your steps, be careful as you're writing your limits, be careful of how you're using your absolute values, because on exams, on quizzes, I will be taking points off if your work has errors, right? So if you're using flawed reasoning to arrive at an answer, you're not going to get full credit. You're probably not even going to get half credit, okay? If you're unsure, you can always ask me. You can take a pic and show me and say, hey, how does this look? And I will, of course, give you feedback on that. But I'm very strict about how you need to write up your solutions. Okay. So now at this point, I'm looking here and I say, what is this limit? This limit is equal to 1. And how do we know that? Well, you can use L'Hopital's rule, or you can expand and divide by n squared. However you get there is fine. That limit is equal to 1. So we just end up with this equal to the absolute value of x. So remember, everything, all of this was to compute L. So L is equal to the absolute value of x. And if L is less than 1, then our series converges. If L is equal to 1, then no conclusion. And if L is greater than 1, then our series diverges. So we can replace L with the absolute value of x, and we'll get, if the absolute value of x is less than 1, the series converges. If the absolute value of x is equal to 1, no conclusion. And if the absolute value of x is greater than 1, the series diverges. So looking on the number line, this means if the absolute value of x is less than 1, that means we are working within 1 unit of 0. So anywhere between -1 and 1. So in here we'll have converge, 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 converge. Outside of here, well, we've got a question mark at -1 and 1. And then outside, diverge, diverge, diverge. Okay. So already we can tell our endpoints in R. So R is equal to 1 because the center, remember the center is equal to 0. So the center is equal to 0. And to find R, we look and see what's the distance between the center and the endpoint. That's 1. So R is equal to 1. And our endpoints are plus and minus 1. So the last thing we need to do is we need to test the endpoints. So let's test our endpoints. At x equals -1, what happens to our series? Our series is x to the n over n squared, okay? So if we plug in x equals -1, then we'll have from n equals 1 to infinity, -1 to the n over n squared. Now this series is absolutely convergent.
It's 12:30.
Since when we look at the absolute value of the terms, this is a convergent p-series. So since it's absolutely convergent, the series converges. Okay, so the series converges at x equals -1. Now, what about at x equals 1? Well, then our series just becomes the p series. So we'll just have 1 over n squared, which converges. Why? Because it's a p series. We just set it over here. So the series converges. So the series converges at x equals 1. So what is our interval of convergence? Well, it turns out that our series converges at the endpoints, so we can go back and update to say that this is included, this endpoint is included, converge, converge. So our interval of convergence is going to be -1 to 1 inclusive. So already we can tell that sometimes when you check the endpoints, sometimes the endpoints are included, right? Sometimes when you check the endpoints aren't included, right? So here the endpoints were not included. And we're going to have a few more examples where we see other versions of what can happen.